Hello and welcome to episode 2 of the Electrium Podcast. Thank you for joining us. On this podcast, we're going to talk about the Big Blue Book, that is the 18th edition, and some of the key things that have come out of the new wiring regulations. Joining me on this podcast is Simon Rowlinson, who's product manager for Wylex, and also group marketing manager for Electrium Mike Cash as well. So we're going to talk about the 18th edition. The wiring regulations came out on the 1st of January 2019, following a 6-month transition period that was published on the 1st of July 2018. And obviously everyone's been talking about some of the key things that have come out of these new wiring regulations. So we thought we'd collate some of the most asked questions that we've heard up and down the country to try and give you a bit more clarity on the things that are coming out of the 18th edition. First question that we hear a lot is on the wiring regulations in general. Why are there new wiring regulations? Why do they change every few years? Gentlemen, what would the answer to that be? And Simon is looking at Mike to kick things off.
There's always a couple of reasons for wiring reg changes. One is to catch up with technology. There was a time when there were no EV systems, no PV systems. So they were still getting installed, despite the fact that they weren't recognised and included in the wiring regulations. And there's a need to bring that into the scope so that they're properly installed. And there's other things that the new regs can introduce to improve safety in electrical installations. The wiring regs are really a safety booklet, and that's the purpose of the wiring regs: keep people safe and provide safe electrical installations.
I totally agree with that. There's not a lot more to add, really, is there?
You know, that's how it works.
I mean, certainly the safety side of the things is the most important thing, I think. And like you say, technology just change over time.
Sometimes there's things that go wrong. You know, there's accidents, there's incidents, and they prompt reviews. Pre-17th edition, there were deaths from electrocution, which resulted in wider use of 30 milliamp RCDs. This time round, there's a big focus on fires, and it's brought about the introduction of AFDDs.
Good. We're all in agreement.
Yeah,
it's always a good way to start off. Right, we're going to talk about arc fault detection devices. Now, AFDDs are a new addition to the 18th edition wiring regulations and have been included to provide protection against arc faults that can lead to electrically ignited fires, and arc fault detection devices have been recommended for this person. But a common question we have already is, do you need to fit them if they're only recommended?
Well, that's an interesting point, but I think I'll throw something over to Mike straight away and say to him, so when they say they're only recommended, but who recommends them? Well,
let's have a look at the phrase "only recommended." That's a sad phrase, incorrect phrase. They're recommended for a purpose, and the purpose is to prevent fires from electrical arc faults in 230-volt circuits. And the people who recommend them are, generally speaking, organisations that are involved in writing the wiring regulations. So those people who write the wiring regulations: IET, NIC, CertSure, ECA, Select, NAPIT, Beamer. Who else, Si?
The Association for White Goods Manufacturers?
Absolutely, the cable manufacturers. They're all part of the process of writing the regs book, and I doubt very much if any of them would say that we shouldn't be following the regs.
Okay, so in terms of AFDDs, do people need to fit just one? Do they need to fit more than one, depending on their installation?
Well, the regulations don't actually specify which circuits they should actually be fitted to. What it does say in the regulations that when you fit an AFDD, it should be at the source of the installation of the particular circuit.
The origin of the circuit, isn't it?
Origin of the circuit, yeah, that's the exact phrase used. So in the case of 230-volt single-phase installations in a domestic environment, that's at the consumer unit. So if you're going to fit an AFDD, there's no specific circuit to fit it on, so you would fit AFDDs on every circuit within the consumer unit.
That's what the regs say, and that's fine. I think some people ask us the question, they believe that the AFDD might be like an RCD and capable of protecting a group of circuits. That's not the case. The AFDD is like an MCB. It's intended to be used on its own individual circuit. So if you've got 6 circuits, you put 6 AFDDs in. If in the same way as you put 6 MCBs. You can't protect them like a dual RCD board, 2 RCDs protecting 5 circuits each. They don't work in that way.
That's not a warning, by the way, with the ambulance going past for that comment. Don't worry. Anyway, Simon, you were going to say something then?
Because they're used on individual circuits as well. They help you comply with 314 of the regulations, which is about circuits when they operate and trip. They don't affect the other circuits within the installation. So it's a very compliant use of circuit protection devices.
And you might have touched on it there, but what would be the other kind of benefits and features then of installing an AFDD?
Well, AFDD, its primary job is to stop potential dangerous arc faults. The thing with an electrical installation, there are arcs being generated all the time. Just as you go through a switching mechanism, when the switch opens, it will induce an arc across the contacts. And the other common arcs that are present within most electrical installations is when an electric motor is running, the brushes on the armature of the motor will generate arcs. So your arc fault detection device, you don't want those tripping on what we call friendly arcs, which are generated all the time within electrical installation. But what you do want them to trip on is a dangerous arc that's been started from a loose connection or a trapped cable with a reduced cross-sectional area, and it creates a hotspot, or damaged insulation on cables or whatever. All these are sources of generating dangerous arcs.
Something else it is brought up is price as well, because there is obviously a certain cost to fitting AFDDs, and somebody asked us in the last few weeks how would they justify that cost to put it into a board for a customer.
Well, don't get carried away with the price is the first thing I would say. Safety in whatever marketplace, in whatever product you choose to buy, it is going to come at a cost, whatever you buy. But with regards to an AFDD, people look at it maybe as a standalone device, but it's not. Often the AFDD is supplied as a composite unit, so it contains the miniature circuit breaker technology, it contains the RCD technology, and it contains the AFDD technology. So you're getting three devices in one. So you've got the cost of the breaker, cost of the RCD, and the cost of the AFDD, all in one. So if you think of it all as an additional cost, that's the wrong way to think of it. It's the cost of things that you're already buying plus a little bit more.
Okay, and with back on AFDDs, it's a new technology for this country. How reliable is it then? The
technology is very reliable. Siemens alone have over 5 million devices installed in the markets where they are required. They're mandatory use.
Yeah, and that's like they're mandatory in Germany, they're mandatory in the States, and a couple of other countries, and they're recommended in a couple more EU countries.
But and the reliability. Like we said before, the software is there to detect dangerous arc faults, and it has a sort of 5 basic criteria that it looks at the arcs that have been generated on the electrical system. For example, it looks at the high frequency power, duration of the incident, high frequency stability, its current value, and the synchronization. And those 5 criteria, it's a bit like face recognition software, where a face recognition software will look for a face with 2 eyes, a nose, a mouth, 2 ears, and 2 eyebrows, for example. And if you match all of these 5 criteria, then that will induce the tripping of the AFDD device. But if you only say have 3 out of the 5 criteria, it's still not enough for the arc fault detection device to trip. So it's all 5 of the instances, not 3 out of 5, 2 out of 5, or whatever.
That protects against false operation. It prevents against nuisance tripping. But the products are manufactured to recognise BSEN standards, same as a breaker, same as an RCD, same as an RCBO. It's an internationally recognised standard. It's been around for a long time. The product standard isn't new. The product technology isn't that new. The new thing is that it's been included in the 18th edition.
Okay, we're going to move on to Transient Overvoltage Protection in a second. Is there anything else you gentlemen want to mention about arc faults at all?
Or why wouldn't you use it? it's going to prevent an electrical fire.
I mean, the only thing I would say is that when an installation is first installed, a brand new installation, from that very first day, the installation starts degrading. Insulation will start to break down with UV radiation and what have you. So
heat,
yes,
on and off, load cycling.
Just using the whole of the installation is the start of the degradation process. So AFDDs, although they may not be used in anger on the first day of installation, certainly over time they will come into their own and protect the property.
There's the DIY angle, isn't there? People do things in their homes. An electrical contractor might well do the first installation, and that's going to be the case for the vast majority of properties. But what happens is people move in, they add a light, they move a socket, they have a kitchen fitted, and over time, apart from what Simon's been talking about in terms of natural degradation from use, everything wears out. You never know what other impacts the tenants bring to the installation, knocking nails in, drilling holes, fixing things to walls. Just negative impacts that can damage cables. So, I like to say, if it's going to stop your house burning down, why not use it?
I mean, that's the key then, really, though. It's safety. It's the key message there.
Well, the whole book, the 18th edition, is about electrical safety. And by the way, they use the word recommendation within the book over 100 times. So there's lots of things where they make a recommendation, like periodic testing, like on C1, C2, C3. There's a variety of recommended actions if you see a dangerous fault. But the book's called Requirements for Electrical Installations. It's not called recommendations if you've a notion to follow it occasionally or when you want to or when you don't. So if you're working to the book, work to the book.
We're going to move on to Transient Overvoltage Protection, or TOP as I like to call it, because I think it's a bit of a tongue twister. Before, in the 17th edition of the wiring regulations, the requirements for surge protection were determined through risk assessment methods. Now, Transient Overvoltage Protection, I really need to make this top. Must be provided in certain circumstances. Right, so first question on this one is, what were the requirements before in terms of surge protection?
They weren't anywhere near as clearly explained as they are now, and they're not that clearly explained now. But there are some distinct shalls in the wiring regs, whereas before you'd look at a map of Britain, you'd look at the flash density, and if your flash density and the number of strikes, lightning strikes, etc., was below a certain level, you'd probably choose not to use surge protection devices. If you were next to a tall building with a lightning protection system on it, you probably would. If you're in a remote location, high on a hill, TT system, you probably would. But the majority of people didn't really look at it and didn't really take a great deal of notice of surge protection for residential properties. Different in process industries where you need to keep the power on all the while. Different for data centres where there's a lot of sensitive equipment. You make a different assessment. But from a domestic point of view, it wasn't widely fitted.
Yeah, I think the focus in the past, though, in the pre-18th, was always on about lightning strikes, and people overlook the fact that you will get surge over voltages down the line just from generic switching actions again. So, you can have faults at the transformer that can lead for the power to be turned off. And when it's induced or reinstated back online, it can give a great big spike and surge in the local vicinity. And any surge, no matter what its sort of magnitude, will have an effect on electronic components. I think it says 1.5 kV. For most electrical equipment, they should have a withstand of that.
Anything beyond the withstanding, you're looking at damage.
Yeah.
If you see damage from a surge, it's a replacement. Printed circuit boards, controls, boiler, that sort of stuff. It's got a lot of electronics into it.
Do surge protection devices interrupt the supply in an event of a surge?
No, they don't. In fact, the best way to look at a surge protection device is actually it's a filter. So when you have standard voltage coming through, if that flows through the filter, no problem. As soon as you get an over voltage, what the surge protection device does, it detects that over voltage and then it suppresses it and puts it back down the earth path. So it removes it from the immediate vicinity.
And then, in terms of carrying out a risk assessment, when does someone need to carry out a risk assessment when it comes to surge protection?
Well, before we get to the risk assessment part, that's the second stage of the latest regulations. The first stage is that there are surge protection devices or overvoltage protection is required where the consequences of an overvoltage lead to certain situations. So, for example, if the consequences of a transient overvoltage could cause serious injury to people or cause loss of human life, and you've made that decision that the building or the type of operation that goes on within that installation requires protection against serious injury or that the overvoltage could cause serious injury or loss of human life, then you provide it. It's a shall, you must. The same for if a transient overvoltage would affect a large number of co-located individuals, a lot of people in one place affected by an overvoltage that leads to the consequences that affect people. You have to provide it. If a transient overvoltage can cause interruption to vital public services, you have to provide protection against that type of overvoltage. They're the shalls. Mm. And there's 5 or 6 listed in the relevant regulation, which is 443.4. For everything else, every other type of installation, you have to do a risk assessment. And it's what they call a CRL, a calculated risk level, but we'll talk about it, risk assessment, because people are familiar with that term. And if your risk assessment gives you a certain value, below 1,000 or above 1,000, then you either have to or have not got to fit transient overvoltage protection. That's really the top and bottom of it. Now, you can look into the regulation for a little bit more guidance and say, oh, does that include houses where nearly all the population live? Yes, it does. But there's an added criteria for houses, and that's about value. So you've done your risk assessment, you've come to the conclusion that you ought to really fit it, and now people are saying, shouldn't we check whether it's worth it or not? And the value you use to make a decision is the value of the installation and the equipment therein, according to the regs. So, typical rewire cost, $3,500. Sorry, Si, you're going to say something?
No, go.
Yeah,
he's got his hand up. He's ready.
He's got his hand up. He's ready. He's going to pitch in a minute. Typical rewire cost, $3,500. Isn't that worth protection? The £3,500 rewire. That's without counting the cost of the equipment inside.
I was going to jump in because there is one other important criteria is that, like Mike said, the second stage is carry out a risk assessment, and there is a sub-stage from that. If you don't actually carry out a risk assessment, you still have to fit a surge protection device.
Sorry, I should have said that.
Yeah,
You're absolutely right. If you don't do it, or you can't get the information to do it, and it is not easy to get the information that you need to know all the lengths of the overhead line, the underground line, and everything else that's leading to the property you're concerned with. So if you're unable to get that information, you can't do a calculated risk level calculation, then you've got to fit surge protection.
And I think that's quite a good criteria to judge against. You're actually making sure that by using the product, the installation is much safer by using the product than not using it and taking the risk.
And then it might be an obvious answer from what we've just spoken about, but what would be the consequences of not fitting surge protection then?
Well, like I said, we said before, overvoltage can lead to electronic components within most electrical items to break down and stop working. And in some extreme cases, overvoltages can lead to inducing fires into the electrical system.
Yeah, absolutely. I mean, we shouldn't really look at the overvoltage regulations without considering all of the places that that we all frequent, if you like. Even if that's on occasion, you might have a visit to a hospital. You know, you might be out at a concert. There's a lot of co-located people. You get an overvoltage, all the lights go off, as Simon said earlier. They're designed to keep the power on. They're designed to avert a fault that could cause control mechanisms and control panels and electronic devices to break down and stop functioning. So these regs apply right across the board to all types of installations. And the designer's got to make a decision on whether or not, first, the consequences apply, whether he can do his risk assessment, and whether he can avoid fitting overvoltage, really. I think the regs basically say you should use them unless you've calculated a risk level that says you don't need to.
Okay, lovely. We're going to move on to RCDs now, and it's another big topic of the 18th edition. And one question we get in is people saying that they've heard that you should use 100 amp RCDs or a Type A RCD to meet the 18th edition. What's the answer on that one?
It's wrong, isn't it?
Straight away,
let's say it's wrong. There is nowhere in the 18th edition that says you've got to use a 100 amp RCD. They don't tell you what ratings to use. You make your decision on what rating of RCD you need based on the load characteristics of either the installation or the circuit that you are working on. Nothing else. And the regs don't say you've got to use a Type A either. They say that you can use the appropriate type. You should always use the appropriate type. And you know, rating of devices, choosing the appropriate rating, is somebody trying to say that that's new? Really? What, have we been choosing the right MCBs and other fuses and the like purely by luck? I'm being flippant, I know, you know, choosing the right device that's not new to the 18th edition.
I mean, you're quite correct there, Mike. I mean, in fact, in the regulations, it actually lists types of RCD that can be used. I mean, they talk about types AC, Type A, Type F, and Type B. All these have specialist applications where they can and can't be used. For example, the Type B, in most cases, is used on areas where there's some inverter DC generation.
PV, EV?
Yeah, PV and electrical vehicles, obviously. So, and that's always been in the regulations, again, from the early days, specialising or detailing the different types of RCD available. But in the 18th, they've took it on to the next stage and now listing all four. And there may be others that will be listed in the future.
I mean, there are some types that are not listed there. I mean, you could count 5, you could count 6, you could count 7 if you want. The regs mention 4, but they don't specifically mention in that 4 Type S, which is now known as selective, used to be called time delayed. They don't mention Type A plus or AA. And if you look across all the manufacturers of RCD devices, the specialists and the generalists, RCD producers, have more than 4 types. There just happen to be 4 concentrated in a little list in one of the regulations. I think really what's happened, and you probably had the same experience here, Simon, people saying, how do I know which one's the right one for my installation? And there's only one way to know that, and that's to talk to the manufacturers of the equipment that are going to go into the installation that you're working on, and make sure that you choose the appropriate RCD to cater for the type of faults that can be generated from either the equipment or in the installation. Okay,
I think we're going to wrap up on those kind of quick questions on the 18th edition. Just before we finish, gentlemen, if there was one thing from the 18th edition you think that will benefit the industry the most, what would you pick?
Oh, that's a hard question, isn't it?
One thing, surely it's got to be improved safety levels, regardless of your opinion of whether the regs maybe go too far occasionally or whether you can't really appreciate what they're trying to achieve. The purpose of the regs is about providing safe electrical installations for people that are going to use and interact with them every day. And whatever additions are put in there, they're there for the benefit of the people who are using the electrical installation.
I think it's probably everybody can look at themselves driving around in cars, you know. in the 60s, people didn't used to wear seat belts, and the drum brakes that were available
no ABS
on the car, that was
no parking sensors.
Everybody thought they were driving a safe vehicle, and over time, and like you say, parking sensors, ABS brakes have been introduced, seat belts are mandatory, airbags.
So it's exactly it.
It's all industries go through an element of improving the safety of using their particular products.
Yeah.
And
health and safety at work. You look on a building site now.
Exactly.
To when I started working on a building site, there was no high vis.
And in fact, if you wore a hard hat on site, you were classed as being very
a little bit
unusual.
soft.
Yeah. I'm glad you said that.
No, I mean, when the hard hats first came out, people used to think of them as a nuisance. They're uncomfortable. What's the point? And all that sort of. You get rejections. You get people not liking to take on new standards, but eventually they become part of the fabric and get taken for granted.
The one that makes me smile is people wearing gloves on site.
Yeah.
Again, that's 20 years ago. You wouldn't have dreamed of wearing a pair of gloves on site, but quite rightly so.
Yeah, absolutely.
You need to protect your hands.
It's all about improving safety, whichever regulations are being rewritten.
Well, didn't we finish on gloves? On the last bit of the podcast. Yeah. But that's where we'll round things off. Thank you very much for listening. You can follow us on social media at Electrium News on Twitter, or Electrium Sales Limited on both Facebook and LinkedIn. If you haven't checked out our first episode already, you can get that on SoundCloud, iTunes and Spotify. Just type in Electrium and you'll find us there. And if you're on iTunes, you can subscribe to the podcast for free. And if you do like what we're talking about, give us a review and 5 stars. We'll appreciate it very much. But for this episode, thanks to Mike, thanks to Simon, and we'll see you next time.